Hello everyone, today we're going to be solving this question here, and this question comes from my first Calc 1 midterm from my undergrad in university. So the question is, let f of t equal 4 minus the square root of t, all divided by 16t minus t squared. The first part of the question asks us to find the domain of f, and the second part of the question says to find all vertical asymptotes of the function. So let's start with solving the first part, part A, over here. So to find the domain of f, we want to see what values of t can be put into the function, what values of t are allowed to be used in this function, and what values of t are not allowed to be used in this function. So let's see if there are any limitations in the denominator, and if there are any limitations in the numerator. So let's start by taking a look at the denominator first. So in the denominator, we know that the denominator is equal to 16t minus t squared. So what in this denominator, what would make this function illegal? What values can we not put into t here, knowing that this is the denominator? Well, wherever the denominator is equal to 0, that's going to be a problem. So let's solve for when the denominator is equal to 0, and we know that those values will not be part of the domain of the function because we can't have 0 in the denominator of the function. So let's find out when this is equal to 0. So what can we do here? How can we simplify this? Well, yeah, we could factor out a t from these brackets. So then we have t times 16 minus t in brackets is equal to 0. So now there are two solutions here for when this function is equal to 0. Either when this factor is equal to 0, the t, so we have t equals 0, and we have 16 minus t equals 0. So the denominator of this function is equal to 0 when t is equal to 0, or when t is equal to 16. So these are the limitations for the domain based on the denominator of the function. How about the numerator? Let's see if there are any limitations of the domain of the function based on the numerator. So in the numerator, we have a term here that is square root of t. Now, based on this, we know that you can't put in a negative number into the square root function. So from this, we know that t has to be greater than or equal to 0. So we've taken a look at what limitations we have of the domain of the function. So here are the limitations that we have. So we know that t cannot be equal to 0. We know that t cannot be equal to 16, and we know that t has to be greater than or equal to 0. So if we take a look, if we combine all of these conditions together, let's put this on a number line so we could show this. Let's say we've got a number line here. Over here we have 0. This is positive infinity, and this is negative infinity. So we know that t has to be greater than or equal to 0. So none of this part is going to be included here. So it's only going to be greater than or equal to 0. And we know from this limitation, we know that there is going to be nothing at the point 0, and we also know that at t equals 16, this is not going to be part of the domain. So from this, we know that the domain is from 0, and we're using a parentheses, not a square bracket, because the term 0 is not included. So from 0 to 16, and again we have a open parentheses, we have a round parentheses instead of a square bracket because 16 is not included, and from 16 to positive infinity. So the final answer is this right here. This is the domain of the function. So this is the answer to part A of the question, which is find the domain of f. So the next part of the question, part B, asks find all vertical asymptotes of f. So let's do part B now. So from what we just solved, we know that t cannot equal 0 and t cannot equal 16. So let's find the limit of the function as t approaches each of these values, and we'll find what the values are there. And if it is an infinite value, then we'll know that that is an asymptote, and if it is some finite value, then we'll know that it is not an asymptote. So let's solve first for this limit, the limit of the function f of t as t approaches 0. This is what we're going to be solving for. So this is equal to the limit of 4 minus the square root of t divided by t times 16 minus t as t approaches 0. So let's plug in zeros wherever we see t's here, and then we have the limit of 4 minus the square root of 0 divided by 0 times 16 minus 0, and that is the limit as t approaches 0. So this ends up becoming the limit as t approaches 0. What is 4 minus the square root of 0? That is 4 divided by the denominator is what? 0 times 16, 0. So this limit here is equal to infinity. So we know that we have an asymptote at t is equal to 0. So let's see if we have an asymptote at t is equal to 16 or not. So let's do the limit of the function f of t as t approaches 16 this time instead of t equals 0. So that is equal to the limit as t approaches 16 of 4 minus square root of t divided by t times 16 minus t. Okay, now if we just plug in the value of 16, what will we end up getting? So let's see, if we just plug in the value of 16, what we'll end up getting is 4 minus square root of 16 divided by 16 times 16 minus 16. So we'll end up getting 0 divided by 0. And from this, we don't know what this value is. So instead of doing this, let's see if we can break up this denominator and get something useful from here. So we'll do this. We'll do the limit of the function as t approaches 16. So in the numerator, we'll keep that the same, 4 divided by square root of t, 4 minus square root of t times t. Now in parentheses, is there something that we could do with this 16 minus t that can help us simplify this value so we don't end up with 0 over 0 at the end, so we could find out what value this function approaches at t is equal to 16? Well, notice that in the numerator we have 4 minus square root of t, and in the denominator we have 16 minus t. So this denominator, we can break this down into 4 minus square root of t times 4 plus square root of t. And we can see if we multiply these two terms together, then we'll have 16 plus 4 square root of t minus 4 square root of t, so that cancels out, minus t. So these two terms here in parentheses, if multiplied together, gives us this denominator again. So this simplification is the same function as this step here. But what is useful in doing this step is we can now see that this term here in the numerator, the 4 minus square root of t, we have that same term in the denominator. So now we can just cancel that out. And what do we end up having? We end up having the limit as t approaches 16. So in the numerator, since this term cancels out, we just have 1 in the numerator here. And in the denominator, we'll have t times 4 plus the square root of t. So if we find what is the limit as t approaches 16 of this function, we will have 1 divided by 16 times 4 plus the square root of 16. And this will simply end up becoming 1 over 128. So this value here, we could see that this is not a vertical asymptote. At t is equal to 16, we could see that this is not a vertical asymptote because this is a finite value. However, we could see that at t is equal to 0, it is a vertical asymptote because over here, the value approaches infinity. From this simplification that we performed over here, we could see that the limit of the function as t approaches infinity would simply end up becoming 0. So based on these calculations over here, we can say, therefore, the only vertical asymptote is at t is equal to 0. And that is the final answer to this question over here. So we solved part A of the question. We found what the domain of f was based on the limitations of what t values could be used in the denominator and the numerator. We put all of these conditions together to see what the domain of f is. And then we found at what values of t there is a vertical asymptote of the function. So hopefully this video was useful to you. If you found this video useful, maybe you could share this with somebody if you think it might help them. You could subscribe, like, comment, all that stuff. And I hope to see you in the next one. So good luck on your studies and take care.